my calculator again, but it's going to be 100 divided by 6. So 50 over 3, whatever that turns out to be. Yep. Oh, no, go ahead. It's because what we're looking for and what we're given. So we're trying to figure out delta x2, and so this equation and the third one down here has delta x involved in it. The reason I chose this one is, and not this one I can't use right now because I don't know how long it took her to stop in the second part here. So I can't use this one because I don't know the time for the part where she hits the brakes. But I do know the final velocity is 0, initial velocity was 20. I know the acceleration was -6. So it's because of what I'm looking for and what I've given. It's kind of like playing football where you're going to throw to some receiver, they're covered. You go to the next one, they're covered. And then finally the third one works. And it takes a lot of practice just to figure out which one to use. But it really comes down to what are you given and what are you looking for? Okay? Okay, very good. So again, I don't have my calculator with me. Actually, this is 400. I forgot to square the 20. 400 divided by 2 would be 200. So 200 over 6 or 100 over 3. So I think this is actually about 33.3. You'll have to verify it with your calculators. Anybody have a calculator with them?
That's what it is.
Is it? Okay, good. That's just for the, go ahead, sorry.
Is there another step then?
Yes, there is. That's just for the second part here.
Okay.
And we still got the distance she traveled over here. So I'm going to write this actually here. Delta x1. Yeah, that's very good. 20 meters per second for a half a second. So here, she actually traveled 10 meters before even hitting the brakes. So the total distance is this one plus this one. So 43.3. So think about that. Before even hitting the brakes, you travel 10 meters. That's probably about from here to the wall. So when you're driving, just, things happen so quick if you just don't pay attention for a second or even a half a second. Okay, so the total distance is 10 plus 33.3, 43.3. Okay? There'll be times during the semester where I say this is the hardest problem we've done during the semester. So this is one of those, but it'll keep building from here. Any other comments or questions on the first part? Okay. And then the second part, if the obstacle is 50 meters in front of her, can she stop in time? Which she can because she travels 43.3, that's less than 50. So she can stop in time. So as far as mastering physics goes, for the first part, you can try the first part as many times as you want to. When it's multiple choice, you can't. If you, this is only between 2 questions. If you get this one wrong, then you can't then put the other answer and get it right. Okay, so multiple choice ones are different than that. Okay, excellent.
Maybe number 2.9 after this?
Sure, yeah. Did you say 2.9?
Yeah.
Okay, good. So here we're kind of mixing units together a little bit. Let's take a look at this one. I'm erasing it now. Oops. Don't want to erase our tools that we're going to be using. Okay. So in 2.9, Major League Baseball, the pitcher's mound is 60 feet from the batter. So as soon as you see feet and miles, just beware. And if a pitcher throws, you might have different numbers than me, by the way. So when we work these out in here, you might have slightly different numbers. Chances are maybe you don't have 92 miles per hour. You might have something else. So just be careful. So mph. And then we want to know how much time elapses when the ball leaves the pitcher's hand until the ball reaches the batter. And we want the time in seconds. So be careful with that too. Seconds. Okay, so maybe it's best to change this to feet per second, and then our answer will actually come out in seconds. We could do it that way. Several different ways of doing this one. Just remember the speed is the displacement divided by the time. So if you put time over here, divide both sides by v, you get this. Distance divided by speed, then we'll give you the time. You just have to make sure that we're working with the same units. If I left it like this, feet and miles per hour, I would be dividing feet by miles per hour, and the feet part wouldn't cancel out. So you have to be careful with the units. Okay, again, lots of different ways of doing this. I'm going to convert 92 miles per hour into feet per second. So you have to look through the book for the conversion factor. Maybe you would just Google it. So I'm going to just Google it and see what that is. And if you've never done this before, you could, if you trust Google, 92 mph in feet per second. 134.933. So you could have actually done it this way, a certain amount of miles per hour per feet. I just kind of just looked it up. This turns out to be 134.933. Okay, so again, you could have looked up the conversion factor. How many miles per hour correspond to a certain amount of feet per second? You could do it that way. I just utilized Google to do it this way. So on the test, I won't have you be converting between feet per second to miles per hour or anything like that. It'll be more straightforward than that. You won't see this English system of units. Okay, so let me utilize this then. Whoops. Okay, so delta x, time rather, delta x, which is 60 feet, divided by 134.933 feet per second. The feet now cancel out, and I'm left with seconds. The seconds pop up to the top here. So whatever that turns out to be. You have less than half a second, though, to react and hit a home run. That's exactly right, yeah. Did you get an answer?
I did it with the numbers I have.
Oh, you get the...
Real quick, yeah.
Okay. Oh, yes, phone. I can use a phone.
I got 0.444665.
Okay. So probably like about 0.45 or something, depending on how many significant figures they want. Again, if you get the significant figures, if it says like 2 significant figures and you give more, they don't count it wrong. So for my numbers, let's just make sure this works. 0.44. It's always nice to see the green check mark too. Okay, so be careful. You probably have different numbers, but that's the way to do it. All right, good. I'm going to do the last 3 also on the homework assignment. Do you have any other ones before we go to that spot, though? Think about it. I'll start doing that while you're thinking about it. Okay. So the last 3 deal with free fall. So all these equations that we have here are good. Right? Free fall is a constant acceleration situation, so it works here. Just note, because it will never remind you of this, if it's in free fall, just under the influence of gravity, you know this. Okay? And you see a delta x here and a delta x here. All you have to do is change that to delta y. This delta x is just like generic this way. If it's in free fall, up and down, that would be delta y, that would be delta y. But it's the same idea. That's why I don't really even almost like to talk about them separately, because it's really the same thing. The only difference is, the acceleration of the y, and these are delta y's. Okay. A gannet, I think is how you actually pronounce this, is a seabird that fishes by diving from a great height. If the gannet hits the water at 32 meters per second, what height did it dive from? Assume that the gannet was motionless before its dive. Okay, so here's actually a point where it'd be nice to have a picture. Motionless means the initial velocity is 0. Now the speed right before it hits the ground, we're calling that the final speed. Not like after it's hit the ground and it stopped, but right before it hits the ground. 32 meters per second, and it's traveling this way. So is there anything wrong with me saying 32 meters per second? It's a good start, but there's something wrong with the direction, right? Needs to be negative. That's what you were going to say. Okay, good. So we got to bring that to the problem. So we're assuming free fall. It doesn't say don't forget this, but I'm telling you don't forget this. Negative 9.8 is the acceleration. And then we're trying to figure out from what height did it fall. Well, if we could find the displacement, this should come out negative because moving this way. If we could figure out how much the displacement is, we can just use the magnitude of the displacement. That would give us the actual distance. Okay, and I think that's all we really know. So if you notice, when you read through the problem, the only number that you actually see there is 32, right, in the problem. But you have to bring so much more to it yourself. Acceleration to y, negative 9.8. Initial speed, 0. You've got to bring that to the problem on your own. And now it looks a lot better. Now we've got 3 numbers to work with instead of just 1. Okay, and again, I wrote these initially for delta x, but you could, because we were talking about the x direction before, you can change them to y, just like this. So for free fall, think of those as delta y's. So here's what we have, here's what we're looking for. We don't have any time, right? Time is not given in the problem. If we wanted to, we could use the first equation to figure out the time. And then once we had the time, we could use the second equation to figure out the displacement. Because we know this and this and this. You could use the first one, figure out the time, and then use the second one, because now you would know the time, to figure out the displacement. Or you could just use the third one right away. We know the final speed, we know the initial speed, we know the acceleration. So it's really just like the last problem that we did. And we could figure out the displacement that way. For fun, let's do it the other way and get the time, and then use the time in the second equation. It really depends on what you want to do. On the test, I'll never say make sure you only use one equation or anything like that. You can do it however you want to. Okay, so to save a little room, I'm going to erase this, but write it up here. So on a test, if you were solving this, you have what you know, what you're looking for, even a little picture. Probably, if you just had this on a test, you would get 4 out of 10. Right? It's about learning how to solve problems. And now we could, we'll do it the way I said. Let's use the first equation to figure out the amount of time. So the initial speed was 0. So remember, that's 0. Final velocity divided by acceleration will give you time. That's coming from the first equation. I'm limited on the amount of space, so this is 0. Divide both sides by acceleration. to get the time. So 32, negative 9.8. I purposely didn't write the negative sign just to say this. If you forgot that this was negative, probably you would realize, oh yeah, that's supposed to be negative. Because right now the time's going to come out to be negative. That shouldn't happen. So that's a little reminder of that should be negative. Okay, so a little bit more than 3 seconds. So once you get the time, then you could use the second equation to figure out the displacement. You know everything else. Again, this will come out to be negative. We just want the height, so we want the magnitude of the displacement. So without putting numbers in for the second part, that's the way to do it. Okay, so get the time, use the second equation. Okay? Any questions on that one? All right, good. Steelhead trout migrate upriver to spawn. Occasionally, they need to leap up small waterfalls to continue their journey. Fortunately, steelheads are remarkable jumpers, believe it or not, capable of leaving the water at 8 meters per second. And we want to know what's the maximum height a steelhead can jump. And part B, if you leave at 8, a steelhead lands on the top of a waterfall 1.8 meters high. How long is the steelhead in the air? Okay. Kind of the reverse of this question. This one was starting at rest, getting down to 32. This one is starting at 8, and how high can you go? So it's kind of the opposite of the previous one. Okay, so we're going this way at 8 meters per second. What's the maximum height? One thing we know at the maximum height, the speed is 0, right? So the highest point, the speed's got to be 0. So you've got to bring that to the problem. And also the acceleration in the y is negative 9.8. Okay, so we also bring that to the problem. Okay, and we're trying to figure out the magnitude of this displacement. So really it looks like the same problem, it's just in reverse. Instead of falling, we're going up. The sign of this, though, is correct. It's going up, that should be positive. Okay? So again, we don't know the time. For fun, I'll use the third one to figure out that displacement. Okay, and using the fact that the final velocity is 0. Okay, so from the third equation then, this part is 0. So picture this happening. This is 0. Subtract initial velocity from both sides. Initial velocity squared from both sides. It's 2a delta y. And again, we're talking about the y direction. So if you want, just to remind yourself, you can put a little sub y on the acceleration, if you want to. And then we'll have to divide both sides by 2a. And that will give us the y displacement. Okay, so minus 8 meters per second. Don't forget to square it. So it's not 8 squared, it's 8 squared, and then there's the negative sign. And then divided by 2 times negative 9.8. Okay, so it's something like 64 divided by 20. So like around a little bit more than 3.2 or something like that, whatever you get. I'm not very good with phones, so by the time I found my app, you'll already give me the answer. So what's 32 divided by 9.8? Actually, let's for fun, let me try one thing. This'll it might not work, but it might. Well, this is on the way up. So when you get to the highest point, you've got to stop for an instant before you come back down. Well, it's the, whoops. So this is a steelhead jumping up into the air. So they want to know like the maximum height. So when I jump, I'm not going to, well, all right, I'll do it. When I reach my maximum height, I have to stop for an instant. That's why this is 0. Right, at my maximum height, I no longer have any speed. That's why it's 0, yes.
I think it's 1.6.
Okay, let me, what did you get, sorry?
1.6.
Okay.
Wait, no, that's 64.
Okay, that sounds good. All right, good. Let me, sorry, I'm doing something different. I'm using my laptop instead of the school computer, so you might have seen my son just notified me. So I closed that out. Okay. All right, good. So it should be about, should be 3.2 then. Oh, what I was going to show you though is you can, I clicked in here. I might be able to do this. So this would be 64 over 2, which would be 32. It might not let me do this, but let's see if it does. So really it's negative 32 divided by negative 9.8. I didn't put the negative signs in. Let's see if it actually works. Whoops. Ah, okay, they won't let you do it. I was trying to show you maybe if you forgot your calculator, you could just put in fractions, but they don't want that. Okay, so don't do that. You actually have to get a number. Okay. Okay, good. Any questions, any other questions on that first part?